Ooh, I've seen better. Today I'll be discussing how jumping works in games and how it relates to player movement. Jumping is an integral part of many games, and ensuring jumps feel responsive and flow naturally is critical to many games' design. I've been working on an open source character controller project in Unity, and we'll go through how I implemented jumping for character movement. Jumping in games is quite important. It determines how the player can interact with specific obstacles, and this, along with climbing, sprinting, and other movement options, can define a game's tone. Whether it's a predictable jump such as in platformers like Mario or Celeste, a controlled jump and fall in a shooter such as Overwatch, or shoving a character in human fall flat, many games include jump mechanics and have them as a core component to navigate the virtual environment. I am using Unity's physics engine to demonstrate jumping and sliding on surfaces for my open source character controller project. This is part of a series explaining the kinematic character controller project. The previous video on projection-based movement, linked to the card in the top right, goes into more detail on general player movement. So, to start off, what is a jump, really? A jump in the virtual world is a bit different than in real life. When you jump, you use your legs to push yourself off the ground and launch up into the air. But when you jump in a virtual space, this is usually just applying some velocity to a virtual object to allow for navigation. If you can't navigate a space easily, jumping can feel constraining and immersion breaking. In a virtual environment, there normally won't be joints and forces unless you're playing a physics-based game like Besieged. Normally, the game cheats and has you control a physics object that applies velocity change to that object to jump. To have a player jump, you can simply apply some upward force to the object and accelerate it down due to gravity. This velocity can then be zeroed out when the player hits the ground so they don't continue to fall through the floor. This velocity is usually set in one of two ways: an instant velocity change, what I'll call a consistent jump, and a sustained velocity change, what I'll call a hold jump. The difference between these two is that a consistent jump is the same height no matter how long you hold the jump button, like Minecraft. This is what I use in my project. A hold jump allows you to jump higher when the hold is longer, think like Mario. These two kinds of jumps have different uses for different games. A hold jump allows for more precise controls and greater depth of challenges, although different games have different requirements. I find hold jump to be a bit difficult for newer players to understand, so I've left it out of my project for now. But the code is adjustable and could be expanded in the future. Another important question to consider is when the player can jump. The obvious answer is when the player is standing on the ground. However, what is considered on the ground? The player in my project can have three different states. 1. On the ground and still. 2. On the ground and slipping when standing on a steep slope. And 3. Not on the ground and falling. How do I differentiate between falling and sliding? Check the angle between the player and the ground. We can use some fancy math here and geometry to measure the angle between the vertical and the normal of the surface they are standing on. The vertical is up and down, the normal vector is perpendicular to the plane the player is standing on. The wedge shape shown on the screen visualizes the angle between the vertical vector and the surface normal vector. The wider the wedge, the greater the angle and the steeper the slope we're standing on. The player will start accelerating down whenever they are either off the ground or when the angle between the ground and the player is over a threshold, 60 degrees for this example. This way, the character will slide down slopes but still be able to walk around them as shown in the examples on the screen now. The player should be able to jump whenever their feet are on the ground. However, this leads to a few problems of being able to jump up a 89-degree incline, so I allow the player to jump whenever the angle is below 80 degrees. Anything more than that and they cannot jump. It's also important to add a minimum jump cooldown to avoid being able to hop up steep inclines. This stops the player from being able to jump up a surface that would otherwise be too steep. I have this set to a quarter second, but it can be adjusted for future projects based on the game's needs. So, it would make sense that a player jumps straight up, right? Well, if you jump off a flat surface, yes. However, if you jump off a slope, you may go in a slight angle from the surface you're standing on. I've added configurable value to my character controller to allow for tuning between these values. I have it turned off in my demo website, but it can be adjusted to have a small influence to make jumps feel more realistic. Imagine something like the slanted walls from Ninja Warrior game show, where you want to bounce off the wall in a specific direction. Additionally, in a lot of games, players want to be able to move while in the air. This doesn't make sense in real life as you move by pushing your feet off the ground, although it feels restrictive in games to not be able to move yourself while falling. How else would you get those perfect shots in Overwatch if you can't move while falling? To account for this, player movement is still allowed as though they were standing on a flat plane, even if they are falling. There are a few more quality of life additions I have added to the project that are found in the most major games. The first is Coyote Time, or a small time frame in which the player will float and can still jump even after they have left the ledge. This makes precise jumping less punishing and allows for more wiggle room. Additionally, I have added jump buffering, a small set of time, about 3 frames, in which the player can hit jump before they hit the ground. This allows the player to jump as soon as they hit the ground, making jumps actions more responsive. Here is a small sleight of hand that my character controller pulls when moving on the ground. I snap the player down short distances at the end of frames to keep the collider on the ground to avoid bouncing off jagged surfaces. This works along with jumping and helps the character feel responsive and smooth in movements. Snapping down especially allows for better walking down stairs. The snap down is computed by casting the character's shape down a short distance at the end of each movement, and then teleporting them down if the ground is close enough to where the player is. Although snapping down must be disabled when the player is jumping or falling, otherwise you get jagged movements and can't jump. Some future additions to this jumping mechanic could include a double jump, such as Genji in Overwatch, a configurable hold jump like in Celeste, a floating fall gliding mechanic like Peach and Daisy in Super Smash Bros., and more player velocity options such as Slippery Ground, as in Fall Guys or Portal 2. I have a simplified version of the kinematic character controller with only the movement and jump mechanics added in the project file Simplified KCC with Jump. Feel free to check this out if you want to see how the source code works for yourself. It has the basic simplified KCC from the previous movement projection video with the jump and a snap down mechanic added. I'm also working on fully documenting the kinematic character controller project at the website in the description. I'll be including text-based descriptions of how various systems in the project work, like these videos, but with greater emphasis on explaining the code in details, easier to search and query. Thanks for watching the video. I've really loved the engagement on these videos and hearing from your feedback in the comments or if direct feedback from social media posts. The channel just passed 100 subscribers, so I'm finally able to give it a custom URL, which was exciting. I was originally going to make a video about hex grids and pathfinding for this week, but that project is taking a little bit longer than I expected. I'm working on adding more detailed documentation from the source code in my projects. I have this for the tile maps and OpenKCC project, and hopefully we'll be able to make it easier for people who aren't able to understand, learn more about the project itself. I have a lot of fun stuff planned in the future, and I'm working on a 100 subscriber milestone video now as well. The channel has been growing very quickly, and I want to thank you for all the support. If you stayed here all the way until the end of the video, you're probably interested in these kind of technical details. Make sure to subscribe if you aren't already, and if you're interested in more content like this. Have a great day!